All right, yay. All right, welcome everybody. Thank you for coming. I'm happy to see everybody here. Actually, we're all happy to see everybody here. And we're here to talk about regulations, but not just not just regulations, but actually what we can do to make complying with regulations open. So that's where the open source comes in, and fun and exciting with generative AI and other open source tools. All right, so before I do that, let's introduce ourselves. Michael is not here.
I will be presenting Michael's content on his behalf. My name is Brooke Wenig. I lead the machine learning practice at Databricks.
Kabir, Rekhi, I'm head of data architecture at RBC Capital Markets.
And I'm Stephen Goldbaum. I'm at Morgan Stanley. All right, let's go.
All right, I guess, so, we want to set the problem statement here as to, what is regulatory reporting and the scope of regulatory reporting. So when we look at it in terms of Gen AI and how Gen AI is going to impact reg reporting, we have to understand some of the themes. So on this visual, we have basically different themes that affect RegTech, and there are a number of regulations which are in place. And in general, when you look at regulatory demand, it's only increasing. So there's a concept of a regulation comes out, and then a few years later, the regulatory bodies rewrite the regulation, and then the rewrite comes out. And when you look at the velocity of how many regulations a typical capital markets business has to undertake, it's increasing. So that's one theme. Then there is this concept of data strategies. Almost every sell-side bank has stood up a data strategy where they're looking at RegTech demand. They're looking at how you can leverage data, how you can effectively reuse data. That's a big theme. So obviously, Gen AI has an impact on making it much more efficient. And regulators have also moved on from just being satisfied by receiving a regulatory report. There's a big controls aspect to it. So now they're basically asking for controls. They're asking to look at controls. There's this concept of defining critical data elements, concept of defining IT controls, accuracy controls. And what they want you to do is have the first line of defense engaged, second line of defense engaged, control testing, controls attestation, lineage capture, and occasionally the regulators come in and ask you questions on operating model and how you're sort of looking at exceptions. So that has additional costs to regulatory reporting as well. And Gen AI has definitely, there's a lot you can do to make that process much more efficient. When you look at common data standards, now this is a interesting development. Recently, there was the US Financial Data Act that was passed where the US regulators have to sort of coalesce on common data models. And this is going to happen. There's a timeline that's been set for 2029. And the same happened in the European Union, and the same happened in the UK, where the regulators have to, by law, comply with common standards. So if they're asking for similar information, they have to ask for similar information on using a standardized template and a common data dictionary, and which is, again, blends very well to the use of Gen AI in terms of mappings, and the team's going to talk about it in detail, like how that's going to make this process much more efficient. And also there is this underlying fact that cloud is here, and reg reporting potentially is being looked at as a prominent use case to move some of the regulatory reporting use cases to the cloud. And when the tech stack changes, the way you look at a regulation, that changes as well. So foundationally, how these 5 themes coalesce into some of the newer trends for using Gen AI, it's basically, if I was to just say this, you look at regulations as an English language rule converted into a standardized rule definition, and that's step 1. And then when you look at that standardized rules mapped into an executable where you're generating a report automatically, that can be done using Gen AI models as well. So today, the team's going to talk about both themes. So Brooke's going to take us through some of the subsequent slides on the modeling side of things. Brooke.
Yes, thank you very much, Kabir. So there's no shortage of possible use cases for generative AI across financial services. And broadly speaking, we see it break down into two key buckets: strategic initiatives and organization change. So strategic initiatives, a few examples are generating new revenues, improving margins. But organization change is how can you innovate more quickly? And so a few common applications of LLMs within financial services: sentiment analysis, document indexing, text summarization. There's no shortage of market insight data, and humans don't have the time to go through all of that text. The average human reads 800 books in their lifetime. Just if you want to have an order of magnitude for how many words we read, the average human, I'm sure the people in this room have read more than 800 books in total, but the average human's read 800 books. The amount of books that ChatGPT was trained on is over 1 trillion. And so if you want to look at order of magnitude of how much data a large language model can ingest relative to a human, it's not even comparable. And so it's really about how we can use these large language models to really accelerate innovation. And so 80% of use cases, roughly, are around operational efficiency. So for example, it's not necessarily about replacing the human, but it's how can we augment them. For example, with chat applications, you don't want to have an LLM automatically reply on your behalf, but instead it could help the human operator suggest the next best action or the next best response to help reduce the amount of time that it takes to have a chat conversation with an end customer. And so lots of different applications: entity extraction, so understanding the data dependencies and complex regulatory workflows, which we'll talk about in a minute, as well as code generation. So from the presentations we saw earlier today, financial institutions have a ton of legacy code base, and it's how can we modernize and migrate that to a more up-to-date system. And so the focus of the talk today is about how can we use LLMs to extract out these regulatory compliance documents, the key regulations, and then how can we actually implement and execute on these regulations. But there's a number of barriers in scaling these AI initiatives. So broadly speaking, I'm breaking them down into business and technology problems. So on the business side, it's risk management. Some of these risks are already present whether or not you're working with AI. For example, exposure of customer data. That's a risk whether or not you're working with AI, but it's a heightened risk when you're working with generative AI. Making sure that any data the model is trained on does not accidentally leak when it's used for another customer. Or issues like prompt injection. So SQL injection is a very commonly known, commonly well understood issue. There's far more ways to do prompt injection with LLMs, particularly in the code generation space. Also the issue of misinformation or hallucination. There's lots of attempts made to try to ensure that the LLM provides accurate responses, but there's no guarantee that it will always provide a truthful response. And then, of course, sophisticated phishing and deepfakes, bias or poisoning in the underlying training data as well, too. On the tech side, there's a few things to consider when you talk about model selection. For example, how do you access the model? Do you own the underlying model, or can you only access it through a third-party API? Are you able to customize or fine-tune that model with your underlying data? So your data is your core IP. If you can customize these models, you, by default, have a competitive advantage over your competitors who any of them could be using the same open source model you're using or a proprietary model if it's not customized. Transparency. Do you have access into understanding how this model was trained? Do you own the model? Control over both the cost and the quality of the model. And then, of course, security and privacy. But the key takeaway is to not invest in a model, but to invest in a platform. The best model today won't necessarily be the best model tomorrow. There's been a plethora of both proprietary and open source models that have come out, and tomorrow there will be another one, I guarantee it. And so the key thing is ensuring interoperability of models through open source. And so we all use open source programming languages. We all use open source tech stacks. Why should it be that large language models are not open source? And so over here, you can see the tech stack, if you were to build it on the Databricks Lakehouse, of how we enable all of these different open source tools to build out your platform. And so one of the key ones that I want to talk about is MLflow. Raise your hand if your organization uses MLflow. OK, one hand up. 2. All right. So takeaway for all of you, I want you all to just recommend to your data science and ML teams, look at MLflow. It's an open source project. It is as simple as pip install MLflow, MLflow.autolog. And the key pain that MLflow solves is when data scientists write code, they don't always write it in the most reproducible way. So I say it runs on my machine, I hand you the code, you have a totally different version of Python, we get into this dependency hell. It helps reproduce the experiments with all of the dependencies, with all of the hyperparameters, so you're not left wondering, hey, what configuration did I run 5 hours ago that didn't work well? So MLflow tracking is super helpful at being able to record and query your experiments, your code, data, configs, and results. MLflow projects allows you to package that up, so it's very easy to share across platforms. And then there's MLflow models and registry to allow you to store and save those models, and so everybody has a clear view within the organization. What is my dev model? What is my staging model? What is my production model? And having a consistent URI for being able to access those. And so it is the most popular open source ML lifecycle management tool out there with over 120 million downloads last year alone. And so MLflow has a few new capabilities for LLMs, including evaluating LLMs. So many of you are probably aware, evaluating LLMs is very subjective. There are benchmarks, but it's not always about your use case or your industry. And so in this case, if I have a task, for example, please summarize this article, but I don't have source of truth, I don't have a way of necessarily evaluating how good the summarization is relative to others. I need to subjectively compare it. And so here, I have 3 different models that I am comparing against, and MLflow automatically logs and tracks all of this for me, so I can see which of these 3 summaries do I think did better for this article, for that article, et cetera. So very easy, consistent way to compare and access your machine learning experiments. Another key feature from MLflow is the MLflow AI Gateway. So today, I know a lot of financial institutions can't use ChatGPT or OpenAI, but for example, you today are using GPT-4, tomorrow you want to use Cohere. And if you want to change the endpoint, it is as simple as a 1-line code change. And the reason why this is super powerful is that instead of writing all this application-specific code, for example, for working with Azure OpenAI, for working with Cohere, it's that it's a consistent interface regardless of what the underlying endpoint is. MLflow manages all of that for you, just 1 line of code change whenever you want to change that underlying endpoint, whether it be an open source model or a proprietary model. And so some risks and benefits of using large language models as your compliance assistants. Benefits, increased productivity. A few risks, regulatory compliance does not allow for interpretation. We need to ensure that there is human supervision and domain expertise here. And to talk about that, we're going to dive into Morphir, which is how we can use LLMs to first extract out the regulatory aspects of these regulation documents, and then how we can turn that into code or executables to ensure that we've properly implemented all of the business logic. Steven's going to talk more about that.
All right, thanks. So Morphir is a FinOps project. It's been here since 2020. And it really is about taking the business logic, the calculations, the rules, et cetera, the most important part of most financial applications, and saving that into a data format so that it's safe from the rest of technology. Because as anybody who's written enterprise software knows, a lot of the time, the important part, the business logic, gets scattered about into different technologies and systems, and we all lose track of exactly what this application is supposed to be doing. And so Morphir captures that into a single location, and it includes the logic and the data. And that can be interesting for various use cases. One of the use cases that we've explored over the past year or so is the regulation called the LCR. We had a few presentations about that last year, and really briefly, what it is it's a regulation that calculates a ratio. It involves categorization of data sets, then aggregation of those data sets, and then applying math and calculations over those. And the trick here is that there's a few challenges. One of the challenges is we have to interpret this. And we want to look at, can we interpret this in an open source way for efficiency and for consistency and all the things that Kabir was talking about. And so in order to do that, we need lots of people in there to do that and then convert that into specifications, or maybe there's other ways that we can do that. The thing that Morphir adds is that where the specification can be ambiguous, Morphir is precise. It's very precise. There is absolutely no ambiguity. What you define in Morphir is exactly what it means and what happens. And so what that means is that we've got this period of specification and refinement. And the refinement is a bunch of feedback tools that Morphir provides in terms of visualizations and testing tools. Anna was in here just a couple hours ago talking about that with Confluent and how that helped with streaming, et cetera. And so we can use those tools to really refine until we've got a precise interpretation. And then from that, we can take that and pass that to different contexts and let it execute in different contexts. And so that creates two opportunities here. One is in that specification and refinement model, because we can add some automation to that, possibly. And then one is that once it's in that Morphir format, it's pure facts. You've got all the facts that you need, that you can think of about your application. What data passes through what logic? What rules apply to what sets of data? If you want to know what happens to your assets as it flows through the LCR, and you want to know what those rules are, and maybe what those rules changed between the 5G and the 6G, or how are they different between the US version of the LCR and the UK version, all those facts are there for you in the Morphir model, and that can also be very powerful for automation and intelligence. One of the other things I'll add is that in refining, it's difficult to really know if you've gotten it right. And so another opportunity is that if you've got interpretation and you've got facts, you've got another opportunity to maybe generate test data that's not just synthetic test data, but it's also test data with results, or at least what we think the results should be, and maybe we need to refine that as well. But that's a huge step up from what we have now, which is no test data at all. And so the question we have is, so what if we can take these large specifications that are in natural language, and we can run that through this process that allows us to visualize the rules and visualize the logic and refine it and fine tune it. And then from there, we can generate the code that runs in our different systems, because we all have different stacks, but we need to comply to the same regulations.
Thank you. So to accomplish this, it's really a two-step process. The first step is, given a regulatory document, extracting out the rules from that document. And so to do that, we're going to use this open source model from Llama called Llama 2 70B, so a 70 billion parameter model, to extract out all of these key entities. Once we've extracted it out, we understand what is required of this regulatory document. We then need to convert this into Elm code so that Morphir can execute it. And to do that, to take this effectively natural language understanding of the regulations, and then to convert into code, we're going to use Big Code Star Coder for that. So it's two different LLMs. First step is extracting out all of the entities and the regulations. The second step is then generating the executable. But there's a number of challenges with this. The first challenge is that most large language models have a very limited context window. So in this case, Llama v2 has a context window of 4,000 tokens. So roughly speaking, like 3,500 words. So you can't pass in one regulatory document all in one pass. And even if it had a large context window, LLMs are notorious for forgetting the middle of the context. So if you think about it, when these models are trained, they often learn that the beginning and the end are the most important things. And so they forget about the middle. And so as a result, we have to break this down into pieces for it to really focus on these given subsections of the document. But as a result, it means it doesn't always have the full context of the document when you're parsing it through. Another challenge is that these models are trained on publicly available data sets. And so there's tons of examples of generating Python code out there, far fewer examples of taking natural language and generating Elm code. And so to accomplish that, you're likely going to need to fine-tune a model for that. And then another challenge is that the LCR regulation is pretty well structured relative to other regulations. And so making sure that we can extract out the entities of other less structured regulations. And so exactly to what Stephen had alluded to of generating test data, we also have to make sure that this code that was generated actually accomplishes what it was supposed to do. And we can actually use an LLM to generate the test examples and then fine-tune it with those examples. And so the challenge here is that when you have LLMs generating test examples, it's not as good as humans generating those test examples. There are plenty of studies that show that the highest quality data is what humans generate, not what LLMs generate. And so to further improve upon this process, we do want to have real Morphir examples, not just the ones that Morphir self-generates, to then go ahead and fine-tune itself. And when I say fine-tune, it means updating the underlying weights to then be able to evaluate the test data. And so you can see here on the right, this is all of the code that we run to be able to fine-tune this model on top of Databricks.
And so really this process is, I think, a little bit like I described before. In this case, FR 2052A, which I'm sure everybody knows, is the specification. That's the natural language part. We bring that into our domain logic model and logic with the LLM. We fine-tune that with humans in visualization and rules through the Morphir tooling. And then we take that and we do other things with it, including generating reports and generating controls and executables for, obviously, we want to run this at some point, and so we've got to execute it.
All right, so the future of compliance. So when you look at the two-step process where the first step is reading the regulation and converting it into rules, and the second step where you're taking the rules and converting it into an executable to generate the actual report, the Gen AI in general can add efficiencies across both steps. And you've got to also, like if you think about extending this beyond just the implementation part, it's controls, it's testing. And there's a lot of efficiencies to be had there as well, because on the whole, the reg reporting regime, it just doesn't end with just sending a report out to the regulator. And on the next slide, we've actually got some additional details here where metadata collection, like mapping what you have in terms of different data dictionaries into one common dictionary, and then collecting rules, applying it to the common dictionary, and converting it into an executable. All that is also possible using Gen AI, and there's a lot of efficiencies to be had there. When you look at technical metadata collection, data lineage, data goes through multiple hops into the reporting layer from where the report gets generated. Potentially, there's use cases there to basically use Gen AI in building the lineage tree, the lineage graph, also data quality and controls. And of course, the regulators themselves are looking at using Gen AI to evaluate the reports that get submitted. So that's really it. And it feels like, where this is, it's an evolving tech space. And we could, like, even if you are not adopting the complete tech stack, you could adopt pieces of building a rules engine for generating reg reports. And all of that's going to help prepare for the future when it actually arrives. That's really it. And then I think we've got, the next slide that really talks about the Finos. We have the Finos RegTech Council, which is what we are part of. And as part of the RegTech Council, there are working groups that have been set up where we are talking about 3-4 different types of regulations and preparing the use cases and detailed requirements as well. So you could look all that information up at the Finos website. I think that's really it. We're stopping here for questions, for some Q&A.
So, this is very cool stuff. Where do we stand in terms of actual implementation? The stuff which you have shown, have we done a POC on it, or are we using it somewhere?
So the stack that was shown has been like POC'd end to end, and I'm sure others can comment to it. We've also have sections where even beyond the LCR use case for post-trade reporting, and we're also looking at ESG reporting. For post-trade reporting, a lot of these artifacts are available in open source today.
And based upon the experience, like the code which was generated, like how much rework had to be done by the developers on top of it? How much was it usable from out of the box?
Yeah, so most of it's POC stage. There are, to answer your first question as well, there's over 20 plus organizations that are using Morphir. In terms of the rework, that one is really more dependent on having higher quality data sets rather than tweaking the code itself.
I was talking about the code which was generated for a
Oh, you're talking about extracting out the regulatory rules?
And then
That
creating the L code.
That part, I don't know about how much the humans had to then go in and tweak. That was Michael's section, but Michael wasn't here, so I'm happy to give you his contact information to get you a better answer as to how much of the regular.
You also showed a slide wherein you were comparing the LLMs. Is that part of MLflow or something else?
Yeah, so this is part of MLflow. So out of the box, open source MLflow. And so with these models that we're training and fine-tuning, you can then log them with MLflow.
So this UI also comes as part of the MLflow?
Exactly, yeah.
Which version is this? Because I haven't seen this one.
This is version 2.8, I believe. Yeah, this might have been a bit earlier, but at least the latest open source MLflow is 2.8. I think this actually might have been introduced in 2.5.
Yeah, it's cool. I will connect.
Okay, perfect.
I got a quick question on the model training. It's a very generic question. Okay, one of the things that people do is obviously use large language models that's already been trained, right? But for fintech, I think you mentioned, Brooke, that there's a need to retrain some of these models. But there's a trade-off about like investing in that training versus wanting to have the model being upgraded again. So like, how do you see that playing out in the industry?
You can see my keynote in about an hour about that. But it really breaks down into 3 different options. You can just use a model out of the box, in which case there's no upfront investment as to do we spend time fine-tuning it, you just use a model out of the box. You can fine-tune a model, and that's actually pretty cheap. That can be as cheap as like $40. It could be a few hundreds of dollars, depending on the fine-tuning. It could even be a few $1,000s. The really expensive one is building your own foundation model, like what Bloomberg did with Bloomberg GPT. That costs hundreds of thousands to millions of dollars to train your own foundation model. And so in terms of organizations adopting LLMs, we always recommend start with an out-of-the-box model, see how well it performs, benchmark it, fine-tune that out-of-the-box model if it's an open source model, and then if you really need to, then look into training your own foundation model. But we would never recommend that you go straight to training your own foundation model without benchmarking those other ones first, because you do have that sunk cost. It's not just a monetary cost, but these models can take 3 to 6 months to train too. And of course, GPUs are limited availability. So typically, we will recommend that you fine-tune a model. The real limiting factor is the availability of high-quality data sets. And typically, when people fine-tune models, it's a mix of both their proprietary data sets and public data sets. Because the problem is if you fine-tune it just on your own proprietary data sets, it might forget some of the information it was trained on. And so that's typically why we see people developing a very intelligent mix of both public and private data sets. Does that answer your question?
Yeah, that really answers the question, and I think it kind of almost begs the question, like, will all the banks get together at some point and create a consortium to enable that type of training on specific bank data, right? So it's just, that's something to see. Maybe Finos will take the lines.
Yeah, that sounds like something you should mention to Finos.
One of the shortcomings of LLM is hallucination.
Yeah.
Right? So other than like you put your in between to kind of pick the better answer or to read out those like hallucination information, what is your pipeline? What is the plan to like reduce the chance of hallucination?
Okay, so actually a question about hallucinations. There's kind of, the main approach people take is to build what we call a RAG system, retrieval augmented generation, which means that, so LLMs can either know things or they can understand things. And so to give you all an example, let's say I have a history exam. Instead of spending 2 weeks studying for it and trying to recall the information from memory, instead let's just say I show up to the exam and it's an open book. I just have to be able to navigate to the right page and then extract out the information from that page. You can expect I would do much better on an open book exam than a closed book exam where I'm recalling everything from memory. And so the idea behind a RAG system is you provide relevant context to the LLM to help ground it. So I'm telling you, hey, the answers are on page 150 and 201. You now have to answer it given those 2 pieces of context. And so building this retrieval augmented generative system really helps reduce hallucinations because you're providing relevant context for it to extract from. It can still hallucinate, though. And hallucinations are very difficult to detect sometimes because there's actually 2 types of hallucinations. There's intrinsic hallucinations and extrinsic hallucinations. And so a hallucination could have a clear statement that contradicts the source. It could also add a detail that wasn't in the source. So it's not necessarily false, but you don't know if it's true or not. And so RAG applications are the main way we see people reducing hallucinations. Another solution as well is having another LLM evaluate whether or not this was a hallucination, and we call this LLM as a judge. So yes, having humans is definitely a good thing, but even humans are bound to make mistakes, especially in those cases where it adds a little piece of detail that wasn't present in the source and you don't know if that was true or not. But yeah, I would definitely recommend looking at building out RAG applications and potentially LLM as a judge.
So the key part of this is basically the fine-tuning of the model, making sure that the testing data it's given is good, as well as the output matches up with what regulators are expecting. So I'm assuming we're involving the regulators in the fine-tuning of this, or are we just sticking with our own internal set of business users? Or is it a question that's completely out of context?
No, it's not out of context. As far as I'm aware, it's being done without the regulators.
So there's two aspects to it. So there is this aspect of coming up with the data standard that the regulator expects, and what regulators expect is as deemed as critical. So there's a number of forums where we are discussing data standards with them, and as the data standards are sort of merging, like a lot of the regulators now want in the post-trade space something called ISO 20010. So like when you go towards a standard, then you go towards a common data dictionary. So that's happening, and that's what's helping. The second bit is interpretation. So it's how you interpret a certain regulation. And in most cases, you would stand up the stack, and you would use it in parallel to test against what you're actually building in production. And when you have confidence, you're going to cut over. And then in the future, when regulations come in, you're going to depend more on this, Gen AI-based tech stack to basically meet those regulatory needs. And that sort of validates, in terms of controls, as how close you are in terms of regulatory expectations. The regulatory involvement is mostly in the case of data standards and what's critical to them. How you sort of deliver on it, it's based on...
It's also a question that highlights the value of FinOS, really, which is...
I mean, I'm also saying this as you know, Steve and I work in regulatory frameworks.
Right. And so without really giving you an answer, because we don't really have an answer because this is very new, but the value of FinOS here is that it is an open source consortium where a lot of the details about collaborating have been taken care of for us. And that's really the forum to start answering those questions.
So, I mean, at least in what you said, one of our primary testing methods right now is just comparing it to previous reports we've generated.
Yeah.
I think we have one more question here.
I'm assuming that you're doing multi-shot prompts to get to the text from the PDF files. And from the PDF, from the text to the Morphir. Are these prompts open source? Is that part of the Morphir project? So you find the prompts. And the second part of the question is, do we need a commercial layer on top from Databricks, or can we run LangChain orchestration?
First question, I would have to consult with Michael about that. Second question, you do need a platform to be able to execute the Morphir code. So it happens to run very well on Databricks, but you could run on other platforms that support Spark as well.
Can you use LangChain for the again, it depends on whether the prompts are.
It's more than just LangChain that you would need, because you would also need to execute the underlying Elm code as well. So you can use LangChain for aspects of it, but not for the entire end-to-end orchestration.
There's also another question directly aimed at promoting FinOS, which is that Morphir is itself just a component of what we just presented. It is a component of capturing the business logic in a data structure and having tools to do useful things with that. We had other open source components in there, including the ones provided by Databricks. So what we just discussed about is not the Morphir project. It is something that uses components of members of FinOS, which are all open source. All right, cool.
Thank you very much.